Hello and welcome. Hello and welcome, everybody, to a new edition of our Wednesday live talk. My name is Chris Armbruster. I'm here today for the AI Guild, and with me are Gráinne McKnight from Spoke.ai and Carl Brenssell, who's also from Spoke.ai. Today's overall topic is going to be about algorithmic fairness, particularly about algorithmic fairness in relation to language models. But I would like to kick off, actually, Grania, by asking you, so we're talking about machine learning, data, and the rest of it today. How did you get interested in data? How did this start for you?
Thank you for having us, first of all. Super excited to be here. So I studied mathematics and I discovered that I loved statistics and probability, which I later discovered not many people do.
Yeah.
And I began working in that field. And what I discovered, in addition to liking the theoretical side of probability and statistics, I discovered I loved building, like engineering. And my family will tell you that I'm terrible at building physical things like furniture or anything like this. But I actually discovered in my jobs that I loved building software and building data products. And to me, data science is exactly that crossover of an interest in mathematics and then a love of building something. So that's how I ended up in data.
Thank you, Grania. I'm going to come back to building things with probability inside in a moment because that's really interesting. But first, Carl, actually over to you. So it says here the co-founder of Spoke AI. How did you get interested in data?
Yeah, thanks. Thanks for having us from my side as well. Great to be here. I come from a bit of a different background in Gráinne. I studied political science, economics, and business. So I was working with both qualitative methods and quantitative methods. I was writing a lot of very long-winded political essays that I'm sure no one will ever actually read. So kind of in realizing that this like very qualitative nature of political argumentation, I got drawn more to the data side because it was very exciting and very gratifying for me and much more tangible to work with data, look at it in different ways, and then be able to directly extract value, which I really enjoyed. And now working more on NLP topics, it kind of brings the two sides together for me. So that's very exciting, having this quantitative and qualitative interplay. And yeah, now very excited to be working on Spoke with my two other co-founders and then a growing team of 11 team members already across 4 countries and 7 nationalities. And of course, Gráinne being a really important cornerstone of that team.
Thank you for that. So, Grania, back to you for a moment about building with probability inside. So, I mean, when you mentioned that building things, physical things, your family says isn't your strongest suit. When physical things are built, I don't know, furniture, cars, and so on, very often the point is that you do not want to have any sort of probability that it's not working or collapses. It's a different kind of problem. But you're building stuff with probability inside, and you said the probability really got you interested. Do you remember, or can you say a bit more about what it is that fascinates you?
I think what I like about, to go back to like mathematics, is the rigor of mathematics. So exactly having a set of axioms and building something from that, and how it's actually quite inflexible. And then what I like about probability and statistics, it's that it's using the same framework, but then it's actually being used to describe something that's inexact and quite flexible. So I think that for me is like, okay, mathematics, and then applied as a lens for the actual real observable world, which we perceive sort of imperfectly. So I don't know if any of that made sense, but basically I found probability interesting because it was like a bridge between sort of rigorous mathematics to the real world.
Okay, interesting. So you're saying that if we look at how the world around us functions, and perhaps how we live in the world, then very often there is probability involved. So this is also a plea for more probabilistic thinking on all our behalf.
Yeah, sure. I mean, I also think there, like, you kind of drew this distinction between building physical things and digital things, and yes, there is some sort of probability or uncertainty in a digital product that there isn't in a physical product. But what I think I would plead people to do is treat them similar in that they both, if you build something physical, it's to serve a certain goal. Like if it's a chair, it's for someone to sit on. I think also building a digital product, it should serve a particular goal, and it should be very clear in your head and not fuzzy at all what that goal is.
Mm-hmm.
And then it's only in the sort of theory behind it that any sort of uncertainty should live.
Okay, thank you very much for that. I'm going to pick up the clear in your head and go back to Carl. So, Carl, you said you didn't become a political scientist at the end of the day, but we're talking today about algorithmic fairness and language models, right? Fairness. So, that is a political topic. It is also about politics. It's also where, say, in both Europe and the United States, politics, regulators, politicians, parliaments have gotten engaged and will get engaged. So tell us a bit more about Spoke.ai, because that's in that field, your role in it. So, politics by another means. So what are you doing?
Yeah, definitely. I think politics by another means is a really good point, and having an impact on people directly is something that I'm really excited about. Even though I didn't become a political scientist. Yeah, maybe first about what Spoke does, trying to keep it short, of course. So basically, Spoke uses AI to empower teams to focus on what really matters by giving them more visibility, autonomy, and meaning in their work. How do we actually do this? We want to empower this team collaboration by automating alignment. And we, from our past experiences, working in large distributed teams that were scaling or were already quite big, we really understand how time-consuming and how frustrating it can be to find, summarize, and distribute information within organizations. So we deliver smartly summarized updates by collecting team progress, making that very, very effortless for people to share what they've been working on, and then distribute this across companies to keep teams aligned. Coming back to the more political side of things, I think super and the more fairness aspect of things, I think we're definitely not in the most critical field of AI. I'm sure there's some healthcare and some credit scoring applications where it would be considered much more critical. But I think it shouldn't really matter which area you're in, because it's always super important to contribute to the discourse about this and be able to push forward fairness in language models and in all interactions that we have with AI. And I think a big point for me and my big excitement about AI and NLP is to push forward this trust in applications that use AI, and make it so that people really feel comfortable interacting with AI-powered softwares and don't have the feeling that it's something scary and something that you shouldn't trust. So we're really trying to be fair there and not and make sure that everyone's progress and everyone's work that they did is then also fairly included in the summaries that we create, which is obviously a small bit, but I think still very, very important.
Okay, so this is about collaboration and at the workplace, and actually fairly representing the people in the company or around the table. Gráinne, back to you. So, founding data scientist at Spoke.ai. So you're a data scientist. You have a mathematical background, but you're also a founding data scientist. So what does that mean? What's your contribution here?
Yeah, so for me, what it means is that I'm part of the founding team of Spoke, whose collective responsibility I see as building the foundations of what Spoke will be in the future. So that includes deciding on a direction, like what value we want to bring with our product, laying the foundations of infrastructure, technical infrastructure to be able to build that product, and deciding broader things like the ways of working within Spoke, what our ethical values are, etc., and contributing to that. I think, of course, everybody who joins a company at any point in time should be able to contribute to all of those facets as well. But to me, being part of the founding team is literally building that blueprint upon which other people can continue to to contribute. In practice, I think what it means is doing little bits of everything across Spoke. So not only traditional data science topics like building and training models and tuning models and assessing performance, but looking at how we set up our data analytics framework, how we set up hiring for the data organization, all sorts of topics.
Thank you for that. Carl, so you have a founding data scientist at the company committed to building that blueprint where other people can then build upon. So I guess the company is lucky. You mentioned earlier, if I remember correctly, that you are at the moment a team of 11 with 7 nationalities. It says in your case co-founder. So co-founder always means there's more than one. So how did Spoke come about?
Yeah, really, really good question. So my two co-founders, Max and Jack, who know each other from working at N26, where they were together for a couple of years, still more in the early days of the company. They've really experienced these issues of and these real pains of a company scaling and the structures kind of not being built for these additional challenges and these additional amounts of people. They really knew this issue there. They started a different company together already, and then realized that they're still very excited to work on this problem that they already know from their personal backgrounds. And then we started doing just a whole lot of user research, speaking to people across very different functions, and understanding what are the really big issues that maybe already existed before COVID and this real rush to remote working and distributed working, and then which one of those even got worse now in the last 2 years. So yeah, it was a lot of user research, and now we are basically focused on product teams because that's something that we understand the best. They are usually very cross-functional. They really know this pain point of communicating with a lot of different stakeholders, and this is something that we wanted to start on. And now we're super excited to have built a really strong core team, and of course are also committed to build this remote first culture because those are the customers that we want to serve, who are having these struggles with be it hybrid or distributed setups. And so we of course wanted to make sure that we are also able to internally include people in different countries and make sure that everyone has a great experience, no matter if they're located in Berlin or elsewhere.
That'll be handy for myself because part of COVID is that I've also become more mobile, so to speak, again. So moving about and working remotely. Thank you for that, Carl. Gráinne, we're also here because the two of you, so Carl and Gráinne, on the 24th of June will be delivering a workshop called Algorithmic Fairness in Language Models. My understanding is that Spoke.ai also provides the background or backdrop to this, and we're gonna drill down on that fairness in a bit more in a minute. But I was thinking that you, as a data scientist, can perhaps say something about language models. So, what does that mean? Could you explain it for somebody that isn't an NLP expert?
Yeah. So language models are how we using them are usually pre-trained language models, which are generative models that predict a set of tokens, so a set of words given some prompt, which is another set of words. So struggling to think of a good example, but let's say I feed a model, I am from France and I would hope that it would autocomplete French, although if I actually phrase it in English like I just did there, perhaps it'd be smarter and say English. And how it learns to predict that next sequence of tokens is by being trained on massive corpuses of data that are publicly available. So this is the internet, effectively. And what has happened over the past few years is that the technical barriers to training massive language models have actually come down quite a lot. And so now we've had a sequence of huge language models being released. So GPT-3 is one example, but there are many others in other markets as well. And these have been shown to be useful not just for the simple example that I gave of auto-completing text, but we can use for a diverse set of machine learning tasks like, for example, classification, or as in our case, summarization or information extraction. So they're really exciting, because to give another example, something like GPT-3 can even do simple mathematics. If you say 1 + 2, it will hopefully autocomplete and say equals 3, which I think is a silly example, but shows that maybe there are far more applications of these language models that we haven't even explored yet. So it's a really exciting area to be working in.
Okay, thank you for that, Gráinne. I'm going to come back to the language models in a minute, and particularly also the language and the different languages and how you deal with that. But I wanted, Carl, to bring you back in, the fairness part. So I'm going to go back to the fact that you have a background in political science and in the social science and political science, right? These discrimination, bias, fairness, transparency, all really important concepts. So how do you see the notion of fairness here and its importance?
Well, its importance definitely very high. Otherwise, I wouldn't be sitting here. But yeah, it's a good question. I think maybe just like to define this algorithmic fairness. I think that we have defined as fairness concerning ensuring that a model performs equitably for all groups of people with respect to protected attributes. So, for instance, we want a model to correctly predict a certain set of tokens at the same rate for men, women, and any other non-binary genders. So I think those are obviously also the examples that we usually think of a lot are probably gender and ethnicity, which are, of course, kind of historically the attributes that are being discriminated on a lot, along with religion, probably. So I think it's very interesting in our case because, of course, we don't have these kind of attributes, or at least we would definitely hope that that this is not a big issue for us. But of course, we have then, for instance, in cross-functional teams, we have different roles that are contributing to the work that's being done in the team. And already there, I think it's very important to make sure that everyone's work is appreciated in the same way, and we don't unfairly discriminate against someone in a, let's say, data science role as opposed to someone in a backend engineering role. That's then a different kind of fairness already, right? To make sure that everyone's work is presented in the same way, and we are able to understand how to be fair on that front. And I think, sorry, go ahead.
Thank you, Carl. Yes. Okay. So it kind of lays out where this is going to go. Gráinne, turning back to you, perhaps. So fairness has some antonyms, if you so like, right? So the bias, the discrimination, and all the rest of it that goes on in it. And language models have come under scrutiny in the past 2 years. There was this big spat at Google that ended up with Google firing its ethics teams for pointing out that there was a problem with its language models. Many people will remember, really a significant event. So how is this with the language models and the bias and discrimination? And is there a difference between languages? So is it particularly bad in English or German? Do you have any idea?
Yeah, on whether it is like worse in some languages over others, I'm not so sure. I would imagine that because some languages actually just there aren't a lot of work or attention being paid to them out there, that the problem could perhaps be worse for those. So hopefully projects like OpenGPTX, the EU's project to build an EU version of GPT-3, which will include like more language diversity, can help with any differences between the languages within Europe. I also think there's some cool work being done. I forget the name of the organization, but GIZ, and they have an initiative called Fair Forward, which is really trying to promote development of model training corpuses for underrepresented languages, like let's say Swahili or some other languages beyond European languages. I think on the topic of, okay, assuming all languages have the same sort of problem with bias, there is lots of interesting work being done on how to de-bias these language models. So often language models are built on top of something called word embeddings, which are ways of representing words or phrases in a mathematical way. And you can kind of see from those mathematical representations which words are related to each other, are correlated with each other. So you could imagine if you found a correlation that was, a correlate of some sort of bias, you could actually remove that correlation in a mathematical way. And
Okay.
we're hoping actually in this workshop to introduce some of those ideas to the attendees. But yeah, it's still currently definitely a problem, but there are interesting methods out there of how to deal with this problem.
Thank you. So, I mean, the focus is on algorithmic fairness. So it's actually, of course, towards providing a solution. And you just mentioned that part of the solution actually means tweaking things in the background in a way. One can think of curating the data in a particular kind of way, or precisely tweaking the algorithm in a particular kind of way to produce the fairness. I was wondering how much it also might revolve around actually, and then Carl, this is to you, kind of measuring the other way around or alerting to the other way around. I'll take a simple example of our audience. So in the English language, at the workplace, relevant to you, there's a way in which the group can be addressed as, hey guys. Yeah, and it's hey guys all the time, and you will see men doing that, you will see women doing that. It kind of everybody's in the hey guys mode, and it maybe the group perceives it as fine, but there is actually an issue there, which is why it's then sometimes hey guys and girls, and then you have it, and it becomes clear. So, what's going on there? How much is it alerting? Towards alerting of practices as they go on, or how much is it towards actually helping a new way of doing things coming about?
Yeah, I think that's a really good question. I think it for sure needs to be a combination of both. I would say definitely. I think it's super important to understand these patterns that are reoccurring all the time. That's a good example of something that we are aware of, and that we are also aware of that this kind of introduces bias. It doesn't include all the people in the room, and it's something that's definitely not ideal. So I think those are definitely things that we should be able to flag and then also exclude from training data, for instance, to make sure that this is nothing that then the model, if you say, hey, can you say hi to the group in this room, that then the model will say, hey guys, because I think that's definitely then the wrong examples to give, especially with the where we want to get to, right, in language and being more inclusive. So I think that's definitely one big part of making sure that we don't have these biases in the training data. And then, of course, we also need to always think about ways of how to improve that going forward, how to make sure that we can use language and kind of promote language that makes it much more inclusive. And I think, yeah, just looking backward is not enough, but just looking forward is maybe also not sufficient there.
Thank you, Carl. I have a question that I've forwarded into the live stream that you can read. Is there a quantitative metric used for measuring bias or a qualitative metric? Rubric. Gráinne.
Yeah. So first of all, I think as we've already kind of discovered in this conversation, bias can be subjective. So it can depend on the context and situation. But assuming you have some agreed upon definition of what bias is for the particular problem, there are quantitative metrics that can measure that. So there's a whole field of emerging research on fairness metrics. So for classification problems, these can be things like a measure of demographic parity, if that's what you're trying to achieve in terms of fairness or equalized odds or equality of opportunity. When it comes to particularly language models, there are what's referred to as WEAT, W-E-A-T,
Okay.
which is basically word embedding association test. And it's kind of the language model equivalent of IATs, if anybody's familiar with those. So they are implicit association tests that you can do online, which kind of measure whether or not you make implicit associations in your head which disadvantage some protected group. So you can Google them, do them yourself, and imagine that we do something similar for word embeddings that we can then present as a quantitative measure of whether or not they're biased. And then qualitative, of course, also, I think it's really important building any sort of AI product to allow people who interact with it to respond, to be able to say, I think this was being unfair, or I think the language used by this was not ideal, to give their qualitative opinion of how it's doing its job, and whether it's doing it responsibly or not.
Thank you for that. Carl, do you have an addition? I think Gráinne said it all. No, I think there's definitely a lot of ways to do it, and I think obviously there's different applications, and it's not easy to generalize for different projects where different biases might be present and might be important. But I think just furthering the conversation about what the different methods are and how we can early on in NLP projects implement measures to understand that, I think is super important and going to be exciting in the workshop.
Yes, exactly. Thank you, Carl. Precisely the topic. So we're closing on the half hour, and for the final round, Gráinne, back to you then for a minute. So you're delivering this workshop. It's going to be a 3-hour workshop. Algorithmic fairness has sort of, there's something idealistic about it, about making the world better and a better place, and that's great. But then also, actually, it's got to work. So it's got, you need to build it, you need to deploy it, and it needs to be there every day. So what's the balance of your workshop? So how much is setting it up, and how much is kind of like hands-on examples and or advice about how to make this happen?
So I think we kind of are going to structure it in 3 parts, which is motivation for why this is important and why it's essential that we look and discuss these topics as a community. A second on measuring algorithmic bias, which we kind of touched upon there. And a third on how to debias algorithms, or how to prevent bias in algorithms. And I would consider for each of those sections that we spend a third of the time introducing the topic, and then 2/3 of the time on discussion and are applying the topic and practicing actually doing that, measuring bias or debiasing word embeddings, or
Thank you for that. Carl, in the best possible scenario, what will the participants take away from the workshop after the 3 hours?
I think they'll have a great time, and it won't be a super dry workshop, as I'm sure we all have attended very, very dry workshops. So Gráinne is there for the agenda, and I'm hopefully more there to keep it engaging and make sure that everyone is involved. I think, as Gráinne said, definitely in the workshop a bias towards actually applying it, testing out different methods, and making sure that you have something. Some hands-on experience and know how to use this in your own project.
Thank you, Carl. Thank you, Gráinne, for being with us for the half hour today, giving a preview of the workshop in June, but also actually talking about your company, Spoke.ai, and your data careers and how all of this comes together. Thank you very much.
Thank you.
Thanks a lot.